This morning we're going to talk a little bit about the basics of static pressure, just as a refresher. Then we're going to talk about some procedures as we wrap up with installation. So, what is static pressure? Static pressure is a measurement of the resistance to airflow. Specifically in an HVAC system, it is the resistance that the duct system and the evaporator coil and the filter provide to the blower motor in the furnace or air handler. So we talk a lot about duct sizing and whether a system has enough return air, whether or not the supply air ductwork is sufficient. We talk about that because it is a restriction to the airflow. Now, in the particular setup we have here, we have sufficient return air, a nice transition, and then of course we have just the modulating motorized dampers. So there's really not a huge duct system on this, and so the static pressure is very low. But when you get into a two-story house where there's, a long extended duct runs going from the top attic into the side attic or down in the first story, these duct systems begin to build up a lot of resistance. And so there's two types of pressure in a duct system. We have velocity pressure and we have static pressure. Velocity pressure is the force of the air, the pressure of the air moving forward in one direction. See, on the end cap of the plenum, what is happening is that air comes out of the furnace through the evaporator coil and hits the end of that plenum, and that is where we convert velocity pressure into static pressure. Static pressure is a pressure that exerts itself in all directions. Everybody understand that? That's why it's important not to put ductwork on the end of the plenum. So, static pressure is resistance to airflow, and it is one of the pressures that we see inside of ductwork.